Okay, welcome everyone to the session for comprehensive AI model deployment strategies. We have seen there are a lot of sessions out here which will talk about like, okay, how do you deploy a Gen AI application? How do you deploy, how do you create an application with LLM models? How do you create an application? How do you code using LLMs, right? How do you run your API calls with LLM? But behind this, how do you secure all of these Gen AI applications by deploying your models on your own network, right? Or how do you deploy these models? There are various different types of model deployment methods that you can use to deploy the models. So we'll go through a couple, I'll try to cover as much as I can. We'll go through a couple model deployment methods, how you can deploy your models in a secure way and self-host the models instead of using like OpenAI models and stuff. So before we get started, let's do a quick Slido. And if you can just scan the code and just give some ideas like, hey, what all AI models you have worked with or deployed in your use cases that you have done till now, if you have any, like just name a couple. Maybe like a GPT model, Llama 3 models, DeepSeek, the recent one that if someone has tested it out, just try typing couple. So I can get an idea what all models you guys have been working on. Okay, I can see DeepSeek and GPT, Claude 3.5. Okay, nice. Okay, Minstrel as well. Okay, a lot of people are trying out DeepSeek. Okay, Llama models. So most of them are using GPT. Okay, nice. Okay, so yeah, I mean, when you are trying to use GPT, these GPT models are mostly, hosted by third party. You are not hosting it. So here's the another one, like what all deployment methods have you used? If you have deployed models on your own infrastructure, have you deployed Tuple? And if you have, what have you used? Like, have you deployed on EKS clusters, on Kubernetes? Have you deployed on, local systems? Or have you deployed on VM machines? Have you deployed on SageMaker, Azure, ML, or whatever, right? So, okay, local. Most of them are doing local. Okay, Azure, because for GPT is using Azure. Okay. Oh, how come it's going on here? Sorry for that. Okay, cool. So yeah, we can see that most of you guys have used GPT models and local deployments. You have used Llama or something. So let's see agenda, what all things we will be covering. So we'll try to see what is model hosting, how do you self-host your models. Then we'll try to look at different model deployment methods, like how do you deploy it on VM, how do you deploy it on managed instance VMs, how do you deploy, what is inference component, how it is useful, what are the use cases for that, what is multi-LoRa hot swapping, and how do you deploy it on Kubernetes. Okay, so 2 years ago, Suzy Compton from Salesforce said that with great power comes great responsibility, and that responsibility comes in form of security and privacy. So given this AI boom, things have become more prevalent from the security perspective, where you have to take care of your data and what data you are sending to your models, right, when you are creating some applications. So we come from security background, so we have to take care of like, how do you make sure that your data is not going to third party, right? So let's say people are using Cisco products and we are deploying some Gen AI applications. We want to make sure that the data that's coming from customers is not going to, let's say, Azure. It's not going to OpenAI. It's not going to someone who is, hosting the models and we are using that. So how do we do that? What we do is we are doing local hosting. So that's where like the local hosting of model comes into picture. What's happening? Okay. So what is local hosting? So local hosting of models is nothing but you are hosting these models on your internal infrastructure. It can be like AWS infrastructure. It can be your on-premises infrastructure. It can be Azure infrastructure, right? What are the advantages? Mainly data privacy, security. You can, it's cost efficient as well because you can do like multiple configurations. You can optimize your own deployment as per your requirement. So let's say you are deploying a small model. In Azure, if you deploy that same model, you are going to pay exact same amount of money for a smaller ML model and also for Llama 3 model, right? But if you are deploying your own infrastructure, you can have like a more concise instance that you can use, more concise configurations that you can use for a smaller ML model. Then comes control over the model. So you have control over who has access to the model, what data is being sent, who can authorize it, right? And then where your data sits, right? So given the GDPR rules and regional regulations, you can use this. So sometimes if you are going with OpenAI will say that, hey, I don't have these models available in in Germany region, or I don't have these models available in Australia region. So in these scenarios, you can do your self-hosting in those regions for these models. Okay, so let's start with the basic thing, right? Like the local deployment. I saw a couple of people have added Ollama. So there are a lot of local model hosting tools available, like Ollama, Llama CPP, LM Studios, GPT4All. These are all like, there are too many tools that are available that you can, deploy your models on your local system and test out, experiment stuff, and do. So most of them are OpenAI compatible, OpenAI API compatible. So let's say you have some GenAI application which you have used with GPT, tested out with GPT. You don't have to make a lot of changes to the code, to your inferencing scripts. You can straightforward use it with these tools because they are all OpenAI compatible, right? Okay. Oh, I did not introduce about myself. So my name is Nikhil Ghodki. I am AI Ops Engineering Technical Leader. I work in AI team. We have been building AI platform since last 2 years. So all the AI assistants that you have seen here, the underlying platform is what we have been building. I come from SRE and infrastructure side. So, and we are also the AI defense. So that's a new product that's coming up. So whatever we are going to discuss here, we have done a lot of experimentation, testing, and we have deployed all these models all by ourselves, and all these applications are using these models, which we have self-hosted. Okay, so let's start with VM deployment, right? So yes, you can deploy your models on your local system, but let's say your team wants to use that same model. You have trained some model, and now you want to share that model with your team, or you want to share it with multiple internal tools to use that model. How do you do that? So let's start with the basic, like, okay, let me bring up a VM. It can be on your hypervisor, on AWS EC2 instance. It can be GCP VM, right? And then why would you bring it on VM, right? So there are like good advantages for that. For example, it provides isolated environments for different environments. So you can basically prevent conflicts between the applications and the model, right? You can have improved security. You can create your own, like it's really easy to deploy with CI/CD pipelines. We do have like multiple pipelines that we created where you get the, the package for the model, you get the image for hosting server, and then you put them together, put it in a Docker, and then just deploy it on VM. So for this, so that's why like it's really straightforward, and then it's very easy to deploy on VMs. We'll see a demo in next slide. So quick introduction about VLLM. I know, can I get a raise of hands if you guys have heard about VLLM before? Okay, so VLLM is a versatile library. It has gained popularity recently because it has a lot, like it supports multiple things. It supports, all the GPUs like NVIDIA GPUs, AMD GPUs, Intel GPUs and CPUs, AWS Trainiums, and multiple other infrastructures. It supports streaming outputs. It supports multi-LoRa as well, so multi-LoRa swapping. It supports high throughput optimization, and it also has tensor parallelism. It supports tensor parallelism as well. So VLLM has like lot of products which are being deployed right now. They are using VLLM library for hosting servers. So let's take a quick demo on how do you host a model on a VM. So we are mostly AWS, so I'll show it on EC2 instance. So I brought up an EC2 instance and I downloaded the GitHub repository for VLLM. Don't worry about, sorry. Oh, did I start it? No. Okay. So don't worry about the clumsiness. I have just tried to redact my account ID. So what I'm trying to do here is I have downloaded the VLLM and I'm creating a Docker for VLLM library, which will help you host the models, right? So I'm creating the Docker and I'm just going to run that Docker. Once I run that Docker, so to run that Docker, I'm adding a Hugging Face. So here I'm going to deploy a Llama 3.2 model from Hugging Face. So I'm adding a GitHub token, Hugging Face token, and what model to be deployed. And with that, I'll run the, I'll run the Docker. So what it will do is, when you're running the Docker, it's actually going to connect to GitHub, Hugging Face and download all the weights, all the config files for Llama 3 models, and then it's going to host it. Now, when it hosts it, we'll try to take an example of how your inferencing script should look like. So if you see here, this is OpenAI compatible script. You can run it for GPT as well. You can inference it using GPT. But here, I've given the base as IP address of my VM, right? The EC2 instance. And then if you see the API key, it's empty because I don't have any authentication set up right now. And then this is just a message, what is 2 plus 4? I'm going to get an inference from there. So if you see here, it's downloading all the safe tensors, which is the weights of the model. And now it's hosting the model on 8000 port. So I'll go and then do the inferencing from my local system. So if you see here, it's going to take some time, okay? Now, what it does internally is it's going to check what model it is, right? What model. So this is a GET API that we have sent, and it's going to get the model name from there. We are going to put it here, and then we are going to create a completion chat completion API, right? So this is what the chat completion API that we sent back again. So this is going to take some time because I have not optimized my VM. Now, when I'm trying to deploy a model on VM, it's SRE and DevOps concern to optimize that virtual machine, right? So if you see here, this is the throughput. You can see 1.3 tokens per second. It's not good throughput, okay? It's very slow. I have not optimized my VM. This is like a vanilla installation of VLLM, okay? Now, it's SRE's work or DevOps work or MLOps work to optimize your VLLMs for throughput, for bandwidth, for CPU utilization, GPU utilization, right? So these are all added, added things that you have to do if you are doing a VM, if you are deploying a model hosting a model on a EC2 instance or any VM. So yeah, you got the output here, and that's pretty much it. Oops, sorry. Now, so to overcome all these issues for the VM, where you have to take care of all the optimization and stuff, we are going to use what we call as managed instance model deployment. So what is managed instance model deployment? You guys should have heard about SageMaker from AWS. You guys might have heard about Vertex AI in GCP. And then there is Azure ML on Azure. There are also other tools called Lightning AI and Perplexity who help you deploy these models on their environment. But it's not like just environment. They are managing your instances. You are doing the deployment, right? Now, let's take example of SageMaker. As I told, we are AWS industry, so we are using AWS a lot. So I am going to give you an example of SageMaker. So in SageMaker as well, when you are deploying on SageMaker, it's very straightforward, right? All you do is you have your weights. So when ML team or data science team, they will train some models. They will package their weights and config files for the models together in a tar zip file. and they'll store it in S3 bucket. They'll tell the MLOps team that, hey, this is the model that you need to go and deploy. They don't have to worry about all the deployment stuff. So we get it from S3. And then the ECR container image is something which are available by AWS gives all these images which have VLLM or PyTorch images, right? Which can help you deploy these, which are the hosting servers. These are model hosting servers. Frameworks that are available to deploy host the models. So we get these ECR images, we get the packages, and then we deploy this. So when we deploy it, we create like why? Okay, sorry for that. I don't know why it's going forward all by itself. So when we deploy it, we create like 2 objects. One is a model object, one is an endpoint configuration object. So the model object will tell you that, hey, what packages I need to use, what is the S3 path. Endpoint configuration will state what instance I should be using. Should I be using G5 XLarge, should I be using G4DNs, should I be using like A100s, H100 instances, right? So you can set like, okay, this is the endpoint configuration, you need to use these instances, this scaling, auto scaling configuration and stuff. So once you create these 2 objects, that's when you go and create the endpoint. So endpoint is nothing but an interface for the instances that you have brought up for hosting the model, okay? And this is what you are going to connect to inference those models. So if you see here, this is a small pipeline that we have created. This is a live pipeline that we are using to deploy the models using GitHub Action, right? So we are creating model, endpoint configuration, create endpoint, and then create inference component. We'll take a look at inference component for the slides, but yeah, that's the pipeline that we are using. Let's take a look at the sample inferencing script, right? So this is a sample code that you can use to inference any SageMaker endpoints. Similar code you can is also available for Vertex AI, right? So if you are hosting it on Vertex AI, similar code is there. So what you are doing here is you are giving the endpoint name and inferencing it, like reaching out to that endpoint and inferencing it. So let's take a quick demo for how do you host LLM model on SageMaker or ML. So I've tried to combine demos with multiple different things. So initially we deployed an LLM model on VLLM. So this time I'm going to share a demo where I'm going to deploy a self-trained ML model. So ML model is nothing but like smaller ML models that we used to run before. Okay, so I'm going to deploy that small ML model on SageMaker. And this model is a transformer-based model, which does classification. We have done it for like 2 classes. One is like, so let's say you have a firewall and you send a question to firewall. So firewall will try to classify, this model will try to classify if your question is for documentation purposes or is it for some policy information that you're trying to fetch from your firewall, right? So that's the classification that it does. So I'm going to deploy this model on SageMaker. This is a sample. This is a script that I'm using for manual deployment, and similar version of like another version of enhanced version of this is something that we are using for the pipeline that I showed you. Here, what I'm trying to do here is I'm downloading the model packages, the package that is tarzip folder. I'm trying to see if there are files and inference.py and requirements files present there. These are required by the PyTorch or the the hosting frameworks that we are going to host these models on. I'm just going to do the checks, then delete the folder from the local system, and then I'm going to create the model. So when I'm going to create the PyTorch model, I'm going to set what's the framework version, what's the PyTorch version, right? And in the end model deployment, I'm going to set what should be the endpoint name, what should be the instance type. So these are like the model object and the endpoint configuration, right? And that's what it's going to go and do the deployment. So this is how I'm going to run it. If you see, it will create the model object, endpoint object, and then eventually it will create the endpoint as well. So when it creates the endpoint, it's actually going to run the. Did it stop? Oh, okay. Sorry. So it's actually going to create the endpoint, and it's going to test it out if it's working fine or not. And then the inference SageMaker.py is nothing but the inference script that I just showed you in the PPT previously, right? The previous slide. So it's going to figure out if your question is for policy or doc. So it's just like inferencing. And if you see here, it's pretty fast than the VM, right? Because here the optimization and everything is taken care by SageMaker instance endpoints, okay? So now moving ahead to inference components. Now what are inference components? Again, inference component is one of the feature from SageMaker, and there is a similar feature available for Azure ML as well. So what inference component gives you is, it's another object that you create, which gives you, how would you create different types of use cases. Like for example, you have, as I mentioned, I deployed a small ML model on one instance, which had one GPU. Now, that model is not going to utilize a complete 100% of that GPU. I want to optimize the usage of my GPU and deploy multiple models on the same instance. How do I do that? I want to deploy multiple containers with multiple different models on a given instance itself, on a given VM. So inference component is something that will give me all these advantages, right? So I can so this will help me optimize my deployments depending on what type of model I'm deploying and hosting. So it's it's really straightforward, similar to what we did before, and it uses like it's very fast, right? So when you are deploying like multiple models on the same instance, it will try to bring up models, and it's pretty fast. Like you don't even feel that there is a lag of like around in milliseconds, like hundreds or 150 millisecond lag when it tries to bring that model in the memory, load that model in the memory. So there are a lot of advantages of inference components. It can scale down the the model, the container, if it is not even being served. So sometimes you deploy like 4 models in an instance, but of which only 2 models are being used a lot, and rest of the 2 models are not frequently being used. So at that point, it's going to scale down those 2 models, and if other models are being used, it will free up that GPU and allocate it to another model deployment. So now, these are some use cases where you can use inference components. For example, for real-time inferencing, for example, like if you are deploying some chatbots, virtual assistants, or you are doing some fraud detections in financial transactions, or some autonomous vehicle decision making, right? These are some use cases where you can use inference component to bring up models in a very short time, and which can also help you do the resource, save on the resources. There's another use case which is like multi-model deployment, which I talked about, which can help you do the cost optimization of your resources. And then there is multi-container model deployment, where you can bring multiple containers. Some use cases here are sometimes, let's say you have like healthcare AI using different models for different disease predictions. You can have like different models for them, and you can host it on different containers on a given instance itself. So these are like some examples of where you can use inference components. Okay. Now, how do you deploy the inference component? So eventually we saw that first we deployed the model object, endpoint configuration, and endpoint. Here, the inference component comes into picture, and each inference component is attached to a specific model object, right? So every model will have their own inference component. Now, you can bring up multiple inference components for a single model as well. Like you say, like, hey, can I have like 2 copies of this model to be deployed, or can I have 3 copies of this model? So that's what you can do. Let's do a quick demo of inference component deployment. Here again, right? So here there are like three scripts that you are using. One is to create the endpoint. You are creating the endpoint, giving all the required details like what should be the instance type, what should be the name. Then you are giving the image URI, what image you should be using. And then you are giving the endpoint configuration details. So endpoint configuration details, I would like to highlight a couple things here. One is basically you're giving the instance type and then manage instance scaling. So if you are enabling the manage instance scaling, it will basically take care of scaling your containers and instances depending on its usage. Right? It can be based on the number of requests coming in, or it can be based on the CPU and GPU utilization as well, right? Depending on what you set, you can do the manage instance scaling as well. Let me start it. Okay. So, yeah. So this is something, and then I'm going to create the endpoint, similar to how we created before. Now here I'm deploying two models. One is for doc versus policy, and another is another use case, which is like policy create or policy configuration, right? So there are two models I'm going to deploy on one instance itself. And then I'm creating the model objects. That's it. And after this, I'm going to use another script where I'm going to, oh, sorry, I did not run it. Okay. So I'm deploying the endpoint configuration and model objects. It's just objects, right? So it doesn't take time. Now, once we have the model objects created and endpoint created, we can go and create the inference components. Now, these inference components are attached to model objects. So that's where I have given the model object names and inference component. Now, here, if you see in the inference component, you can see there are a couple. Okay, something is. Okay. So here, if you see here, we have added compute resource requirements. So this compute resource requirements is something that you can basically adhere a specific model with specific, like let's say for model 1, I'll say, can I reserve 1 GPU for model 1 or 0.5 GPU for model 1, 0.25 GPU for model 2, right? And also I can state that, hey, can you reserve this much memory for model 1, model 2, model 3, and so on. So you can basically reserve a specific compute requirements for a specific model as well. And then I'm just going to go and create the inference components. Okay. So it should create the. I'm so sorry, I don't know what's happening here. Okay. So if you see, it has created the endpoint inference components now, and then we are just going to go and do the inferencing, exact same scripts. But if you see in that script, we have added the inference component as an additional attribute. Right? So if you see here, it has both of these models are deployed under same instance. So I have used one instance and deployed two models in it instead of doing it on two different. So I'm trying to optimize my resources. I'm trying to save my money, but I'm also deploying both of these models as well. Now there are other load testing and performance testing and everything. You have to take care of bandwidth utilization and everything when you are doing all this deployment as well. All these configurations are available in the inference component configurations. So yeah, that's about this video. Now let's take a look at multi-LoRa hot swapping. So this is a very interesting topic. Can I know how many of you have heard about LoRa adapters or LoRa? Okay, so LoRa adapter is basically, it's a technique. So LoRa is a technique of fine-tuning models. So So it's a technique of fine-tuning pre-trained models efficiently with, like, you only train like couple of small subset of your weights of the model instead of training the complete or the whole model as it is, right? So so these low rank matrices are something that you're training and putting it in specific layers of the model weights. So in this scenario, when you're trying to bring up the LoRa's, they load up in the memory. They act as if they are the complete LLM model, but they are not. They are just subset of the weights of the whole model. And then you bring up in the memory where the base model from which you have trained these LoRa's is already running, right? In this manner, let's say you have use cases of you are trying to train your LLM models for specific use case. So let's say there is Meraki. You are using Meraki APIs, and you want a Llama 3 model to be trained for all the APIs to be for that LM to answer any questions for those APIs. Now, instead of training the complete model, all you do is you train like specific subset of those weights, and that's it, right? The advantages are the main advantages are like it is low memory footprint. It doesn't use a lot of memory. Second, training time is very low. You don't have to spend on like months and months to train a LLM model. You can train it like in 24 hours to 48 hours. And it's like when you are deploying it, when you are inferencing it, it uses very low resources, right? Like basic resources that are required for one single LLM model. Another thing is you are optimizing things. So instead of deploying multiple trained LLM models, you are just deploying one single LLM model, and then you are deploying these LoRa adapters. Let's say hundreds of LoRa adapters you can deploy in a single instance, and you can use it as if it's like multiple LLM models you have deployed. So how does it work, right? So here, as I mentioned, let's say L1, L2, L3 are three different LoRa adapters, right? Which are like in couple MBs, like 20 MBs or 13 MB adapters, which I have trained. Let's say one for Meraki use case, one for OpenCV use case, one for firewall use cases. So all the APIs, right? So I've just trained like LLM models for that. So these are adapters. And then on one instance, I have deployed a Llama 3 model, okay? And this is LoRa Exchange. So LoRa Exchange is nothing but it's a router. When you try to inference the model, you state that, okay, I am inferencing it for Meraki APIs. Give me, pull up a model load the model in the memory, which is for Meraki. So what it will do is it will get that request. Based on that request, it will basically load the adapter in the model memory, in the memory of the instance where the models are hosted. And similarly, if you see here, it is hosting these three LoRa adapters, and it can host multiple LoRa adapters. Another advantage or interesting fact about LoRa is you can even create networks between the LoRa adapters. So let's say I ask like, hey, how can I create a policy for this in Meraki or something? So it will try to use Meraki and firewall APIs. So there are two, L1 and L2. It will try to go to L1 first, and then it will go to L2 within the model itself, and then it will give you the output for that, right? So you can create a network of requests through multiple LoRa adapters. So it's very efficient, very cost effective, and very simple to deploy as well. We have, so if you have seen the AI Defense product that we are going to bring up in March, that is using this LoRa adapter. There is a unified AI assistant that we are bringing up. It is using the LoRa adapters on the back end. For multiple products. So it will have like one unified UI where you will ask any question for any product, and it will basically go to this LoRa and it try to figure out what product you are asking this question for and answer accordingly, right? So that's what we have deployed on the back end. Okay, so again, going to the technicalities, this is again simple. So these are like simple chat completion APIs. Here you can see when you are making a request, it actually tries to, you have to give the, sorry, you have to give the LoRa adapter ID with that each request. So this was when LoRa came up like a year and a half back. But now even this has improved. You don't even have to give the LoRa adapter ID. You just send a request, sample request. It will try to figure out. It will do the classification and routing to the specific LoRa adapter. Let's take a quick example demo for this. So let's do a quick demo for this. What's happening? Okay. Okay, so here I'm deploying this Llama 3 model, and this is the image that I've built for LoRaX, which is LoRa Exchange. And my adapters are on Hugging Face, so I've given the Hugging Face ID, and then I'm going and deploying the LoRaX, right? So LoRaX is similar to what we deployed the VLLM, right? So it's similar to that. I'm creating the endpoint, SageMaker endpoint with LoRaX. And so at this point, it's only going to deploy the Llama 3 models. The adapters are still on Hugging Face. You can store it in Hugging Face. You can store it on S3 buckets, everywhere. Don't worry about this. This is where it has created the endpoint. And I'm just going to inference it now. Something is wrong here. OK, so if you see here, so this is the inferencing script, right? So here, I'm going to give input as what should be the adapter ID and for every question that I'm sending. So there are two input questions that I'm doing. One is for Meraki, one is for OpenCV, and it's going to send them to that one single model, right? Hey. So I'm going to inference it and see. So these are two questions. One is for Meraki, and second is for OpenCV. It's going to give me an output as to, OK, if you're sending this question, then what should be the API that you should be running, right? So that's how it's going to give you the output. So this is for a pre-trained LLM model, all right? So you can't get this directly from regular LLM models. You have to pre-train those models. So that's a short demo about LoRa. But trust me, this is a very interesting scenario where the use cases here are a lot. You can, let's say, there is a use case where you want to deploy an application where it needs to go through multiple LLM models, right? So in here, all you do is you train these LoRa adapters, and you use the internal LoRa mesh to send this request through those multiple LoRa meshes, right? So yeah, and at last, Kubernetes model deployment, right? You can deploy a model on Kubernetes. This is very prevalent. Most of you or most of the people are using this right now. What are like use cases of Kubernetes, right? So again, if you already have Kubernetes, if you already are deploying your applications on Kubernetes, it's very convenient to deploy even models, host models on Kubernetes. It's within the same VPC. All you need to do is deploy some CRDs. Like for example, Kserve. So Kserve is one of the tools that you can use to deploy or host models on Kubernetes. It's also similar to VLLM. It's a very versatile tool which supports almost all types of GPUs. It supports Kubernetes, but there is one more layer that it needs, which is Knative and Istio. I know a lot of people are afraid of this. Even I'm afraid of Istio. But yes, I mean, the Kserve, it provides an abstraction layer over the Knative and Istio for model scaling, and whatever we discussed for inference component is something that Kserve also provides. And then these are like supporting serving frameworks that it supports. They have recently added a couple more as well, like TensorFlow, PyTorch. PyTorch is one, TensorServe, XGBoost, right? These are some serving frameworks that they support. So when you're deploying this Kserve, as I mentioned, it's an abstraction layer over the Knative and Istio. All you need to do is you go and deploy the CRD, which is inference service. It will go and deploy your model pods. It will go and deploy the services, load balancers, whatever things are required to deploy your model. right? Uh, and at last, this is the model mesh serving in Kserve. So you can basically have multiple models deployed. You can create a mesh using Istio, and then it's almost straightforward. Right? If you are working on Kubernetes, there is nothing different in here. It's just an additional CRDs that are created, and you are deploying your models on Kubernetes. So that's pretty much it. And with this, these are like some model deployment methods that I wanted to cover up here. All the codes and scripts which I've shown on the demo, as well like a couple more like for Ollama and stuff, I've added in this open source GitHub repository. If you guys want to, you can access this. And at last, if there are any questions, please you can reach out to on the WebEx app. Go to the DevNet 2905 and ask me any questions if you have. It will be open till February 28th. And please fill out session surveys. It's really important for us. And if you fill out like more than 4 session surveys and a complete session survey, Cisco Live survey, you might even get T-shirts. So. And for continue your educations, there are a lot of talks that are going to happen for AI defense as well as AI assistants. And just to let you know, all of these methods that we have discussed right now, they are all right now deployed live for AI assistants and AI defense products that we have built and which are coming out. So if you attend those seminars, sessions, you will try to, you can get a background on that. Okay, thank you so much.